Thanks all for being here. So I'm getting started here. Thanks all for joining the talk. My name is Dong Song. I'm a professor in computer science at UC Berkeley, the co-director of a new campus-wide center at Berkeley called Berkeley Center for Responsible Decentralized Intelligence, and also the founder at Oasis Labs. So today I'll talk about data sovereignty and decentralized data science in Web3. As we all know, data is a key driver for modern economy and the lifeblood of AI machine learning. And more data is being collected every day, and personal data is now a significant fraction of global GDP, and it's increasing exponentially. However, a lot of this data is sensitive, and handling the sensitive data has posed unprecedented challenges to both individuals and institutions. So for example, individuals have lost control over how their data is used. Oftentimes their data has been misused or sold without their awareness. And also, a lot of the data has been sold under the premise that they have been anonymized. But however, a huge volume of research has shown that anonymization is insufficient to protect users' data privacy. And also, for institutions, they continue to suffer from large-scale data breaches, where hundreds of millions of users, or even billions of users' sensitive data was stolen by attackers. And the privacy regulations has also made it more and more cumbersome and expensive for business to comply. And the biggest issue is it's still difficult to actually utilize data. So the valuable data is now often sits in data silos and is not being utilized due to privacy concerns. So all these pose significant challenges, and they are only going to get more and more severe as we move forward in the digital era, to the extent that if they are not addressed, they can severely hinder societal progress and undermine human values and fundamental rights. And hence, there's an urgent need for a new paradigm that I call a responsible data economy. So what do I mean by a responsible data economy? So first, so there are a number of goals and principles. So first, we need to establish and enforce data rights. These data rights serve as foundation of data economy and prevent misuse and abuse of data. And two, we need to enable fair distribution of value created from data, such that users should be able to gain sufficient benefit from their data. And most importantly, we want to ensure efficient data use to maximize social welfare and economic efficiency. So today we are in the era of Web 2, where a platform maintains centralized control at all layers of identities and data, where identities are managed centrally by service providers. Data is maintained in centralized data silos, and data is often processed without the knowledge of the users. And to address the challenges I mentioned earlier, we want to move into the paradigm of Web3, where users are in control through this decentralized paradigm, where we can enable decentralized identity, decentralized access control, and also something we call policy-compliant decentralized computation, such that we can control, users can control the data usage without relying on intermediaries. A number of new technologies that I call responsible data technologies, when putting together, can help us to shift into this new paradigm. So these responsible data technologies include, for example, secure computing that helps protect the computation process from leaking sensitive information, such as using secure hardware or cryptographic methods, such as secure multi-party computation, fully homomorphic encryption, and so on. And then differential privacy that ensures the computation output won't leak sensitive information about individuals and the sensitive input. And with federated learning, it ensures data stays, while data stays on owner's devices, the different devices can together train machine learning models and do data analytics in a distributed manner. And with distributed ledger, it helps provide an immutable log to ensure that users' data rights and data usage is compliant. So now At Oasis, we have been developing various technologies to help ensure responsible data use and so on. And I want to share a case study and a project that we have launched recently together with Meta. This is the first of its kind, large-scale real-world deployment for privacy-preserving AI model fairness assessment. So in this case, the goal is to do fairness assessments for AI models used, for example, by Meta and Instagram. So as we know, with AI becoming more and more ubiquitous and making automated decisions, it's important to ensure that these AI models are fair, that's not biased on gender, race, and so on. So then it's important to actually measure the fairness of these AI models. And there are different metrics for AI, to measure AI model fairness. So for simplicity, essentially here, we want to measure how the AI model inference results, how they compare according to certain sensitive attributes, such as users' race or gender, and so on. And so, for example, comparing the average inference results of users identified as different gender and so on. So in order to do this computation, it needs a lot of sensitive information. It needs users' sensitive attributes. It needs the users' inference results. And hence, it's really important to be able to do this computation in a privacy-preserving manner. And this is where the Oasis technology comes in, where we have developed and combining different types of privacy-preserving technologies that I mentioned earlier, by combining secure multi-party computation, and homomorphic encryption, and differential privacy, and even some zero-knowledge proofs. We have together developed this new privacy-preserving platform in collaboration with Meta, and this has been rolled out to essentially all Instagram users. And then this data enables the measurement of AI model fairness for Instagram. So this, again, as I mentioned, this has been the first of its kind large-scale real-world deployment. We have learned also some important lessons and challenges from this experience. The challenge here is that developing developing the algorithms and protocols, it takes some time, but actually it takes much longer to actually do the real-world production quality development and deployment. So today, this type of decentralized data science and responsible data use today is simply too expensive. And there are a number of reasons why they are expensive. Essentially, there are many challenges when you develop this type of decentralized technologies to enable decentralized data science. And so this is in essentially in analogy with, for example, for deep learning, when before PyTorch and TensorFlow was developed, it was actually very difficult, labor-intensive to even develop and train small neural networks because the programming abstraction wasn't there. So similarly here, for developing decentralized technologies and decentralized data science, we need better programming abstraction to make these things easier. And also today, the different types of decentralized systems, they often stay in silos and are difficult to actually compose. For example, for federated learning, there are over a dozen different types of federated learning frameworks, and each one sits in its own silo, and it's actually very difficult for developers to use and so on. So this motivated us as a research project. At Berkeley, we have developed a new system called CoLink that actually provides a system that essentially provides this decentralized programming abstraction. It has built-in programming abstraction for decentralized identity, private storage, secure communication, and decentralized protocol encapsulation. So when we put all this together, it essentially makes it much, much easier to develop new decentralized applications and solutions and systems. So for example, the example that I mentioned, the work with Meta, using this new framework, instead of taking it many months to develop the system, it would reduce the work to just a couple of weeks. And also here's another use case example where, again, using this framework is very general, so you can develop lots of different types of decentralized solutions. So this is a command-level supervision for SSH, where you can simply, using the system, just very quickly, you can develop a supervised SSH where the server owner can observe remote guests what commands they run and can approve or reject certain SSH commands. So with all this together, this programming abstraction together, we also developed what's called CoLearn. It's a unified platform that integrates different state-of-the-art cryptographic protocols for federated learning, for secure multi-party computation, and even for key management and so on. And so with this CoLearn platform, it enables a new open source platform for making decentralized data science easy. And it helps bridge the gap between crypto protocol design and real-world deployment to make it orders of magnitude cheaper and faster to develop and deploy decentralized cryptographic protocols, and also make these protocols composable in a unified framework, and builds a preset of carefully designed and standardized decentralized programming abstractions to, again, make decentralized data science and other decentralized applications much easier. So with CoLearn, it can help accelerate the research, development, and deployment of decentralized data science. It helps researchers and protocol designers to have faster and easier deployment to lead to greater impact. And for application developers, it's much easier for application developers to utilize these protocols as building blocks in their applications. Oftentimes, they can incorporate these decentralized protocols with just one line of code, and also helps the community to come together to enable better reproducibility, better reusability, and build an ecosystem. So with this, then it helps individuals to maintain better control of their personal data, to provide stronger privacy and security guarantees, and also help them gain more benefits and fair value from their data, and helps companies and organizations to better utilize their data and build better products and services. So with all that, so again, today we are in the Web2 world. However, with the new regulations, it also helps, it actually helps users to gain more rights on their data. For example, one of the rights in GDPR is called the rights to data portability, where it essentially makes it required and also makes it easier for users to download their data from different third-party services. And then users essentially can bring this data from third-party services into their personal data vault. And so with the platform for decentralized data science and also the technologies that Oasis has been building, we can build what I call data commons for decentralized data science, where data owners and producers, they can provide their data in encrypted form in this decentralized platform, and register their encrypted data sets with data use policies on distributed decentralized data catalogs. And data consumers and analysts can search these catalogs and find relevant data, and then they can write their data analytics and machine learning programs over these different data sets and data sources to try to utilize the data. And then they can submit these data analytics and machine learning programs to this decentralized data science platform, which then essentially provides secure computing to utilize the data and ensure the data is utilized in a compliant manner with the desired policies, and to produce, in the end, the results. So with this approach, we can significantly reduce the friction of data usage, remove data silos, and provide stronger protection for security and privacy. So I strongly believe that in 10 years, this type of data trust and data commons will become predominant. In 10 years, data trust and data commons will become predominant ways of utilizing diverse sources of data, enabling ownership economy where users benefit from their data as owners and partners. And in 10 years, the data stewards, fiduciaries, and trustees will be a new class of entities important in the data ecosystem to help manage and protect users' data and grow its value. And in 10 years, huge economic value will be created through these new platforms of data trusts and commons, order of magnitude higher than today's marketplace. So with this new approach, we hope that we can really enable this paradigm shift, shifting from centralized control in Web 2 to user control in Web 3. So with this approach, we can help make decentralized programming and decentralized data science easy. So that's about how we can actually build public goods with this data commons and decentralized data science. So I also want to just briefly make an announcement that we, so at Berkeley also with RDI, we have just launched a new ZKP and Web3 hackathon. It started March 1st. The sign-up opens on March 1st, ends on May 2nd. And this is in collaboration thanks to many partners and sponsors with up to 200K plus in prizes, and many leading researchers and cryptographers as judges and so on, and has a number of tracks in the hackathon to enable decentralized collaboration for the community to come together to build the key zero-knowledge proof technologies. And it's hosted by Berkeley RDI, where I'm also a co-director, which aims to advance the science and technology of Web3 decentralization and decentralized intelligence. And you can learn more about RDI also and the research at RDI's website. And what I want to mention is here is many of you, if you are interested, you can check out the MOOCs. So we have led, in collaboration with other institutions, we have led a number of MOOCs, including the DeFi MOOC, the Entrepreneurship in Web3 MOOC, and also currently we're running the ZKP MOOC. You can go to zk-learning.org to learn more about the MOOC on zero-knowledge proofs. And we have over 3,500 people enrolled across the globe. And that's also why we are holding the ZKP hackathon as well. And for people who are interested in building new ventures, you can also check out the Berkeley Blockchain Accelerator, which has incubated 85 teams with a total follow-on funding for over $450 million. So with that, again, you can by going to the check out the barcode for the ZKP hackathon. And with that, thanks everyone.